Alright kiddos, hope you're doing well. This video I want to introduce to you the two key players in trigonometry, right, which is a different kind of function. It's not algebraic. So the two main functions I want to introduce here is I want to define the sine and the cosine. The sine and the cosine. They're two functions, and here's how they work. Both of them can be defined within the context of what's called a unit circle, right? So I'm going to create this circle whose radius is a unit, right? So if this point right here is the origin, right? Because the radius has 1, that means this point out here is 1, 0, right? This radius is also 1, so this point up here is 0, 1. Move over 1 from the origin to the left, negative 1, 0. And the point down here at the bottom, I'm going to move down 1 from the origin, so I get 0, negative 1, right? Remember, the first value is the x value, right, left, and the second value of the coordinate is the y value, up, down, right? So this point 1, 0 means from the origin, 0, 0, I move to the right 1, that's the x value, and then up 0, so I stay there, right? The point 0, 1 means I start from the origin and go to the right / left 0, and then I move up 1, so I end up here. Okay, etc., etc. So that's where we're going to start. Now, this radius here, I'm going to call my initial radius, and that has a length of 1. Okay? I'm going to rotate that, right? I'm going to pretend there's a safety pin here, and I'm going to rotate this radius, and I'm going to wind up at some point here, right? The point at which I land is called the terminal point. Right? And so after I rotate x degrees, the radius is still 1, this point right here is called my terminal point. Now by definition, at least the unit circle definition, the x value of my terminal point is defined to be the cosine of the angle that got me there. COS is short for cosine of x. X is the angle that I rotated. Right? The y value of my terminal point is defined to be the sine of the angle that got me there. Again, x is an angle. So sines and cosines act upon angles. Okay? And that is how we build sine and cosine. They both act upon angles. So let me give you an example problem. So we're trying to build an understanding, for now, basic understanding, of what does it mean to take sine and cosines of really nice numbers or angles. So for example, what would the sine of 0 degrees be? Right? And so using the unit circle, I'm going to start with my circle, 1, 0, that's 0, 1. This point here is negative 1, 0. This is 0, negative 1. Right? And I'm going to start here with my initial, radius. Pretend there's a safety pin there at the origin. I'm going to rotate to evaluate the sine of 0. I'm going to rotate 0, right? So I don't go anywhere. Okay. By definition, the terminal point, so this is my starting point and my terminal point because I rotated 0 degrees. By definition, the x value is the cosine of the angle and the y value is the sine of the angle, right? So therefore, the sine of 0 degrees is going to be the y value, right? 0. While we're there, what's the cosine of 0 degrees going to be? Yep, that's correct, the x value, 1. Okay? What if I asked you what the cosine of 270 degrees was? Right? Well, let's start with the unit circle. There's my point 1, 0. And in the interest of time, I'll just label that 1.10 for now. And now with my safety pin affixed at the origin, I'm going to rotate this radius of 1 270 degrees. Right? Up, that's 90. That's 180. There's my 270 degrees. Right? So this point right here is my terminal point. And that, by the way, happens to be the point 0, negative 1. Right? So I rotated 270 degrees, and because I'm looking for the cosine of 270, I remember that the cosine is the x value of my terminal point. Therefore, the cosine of 270 degrees, is 0. While we're there, what would the sine of 270 degrees be? That's correct, -1, the y value of the terminal point. How about this one? What if I asked for the sine of negative 90 degrees? Well, if a positive angle of rotation, we rotate counterclockwise, what do you think we would rotate for a negative 90-degree angle of rotation? That's right, clockwise, right? So I'm going to go down. So again, I'm going to start right here, the radius 1, put a little safety pin at the origin, and now I'm going to rotate this guy -90 degrees, right? So a -90-degree angle of rotation means instead of going upwards 90 degrees, I'm going to move downwards 90 degrees. Right? So negative angles have a context now, at least for trig, sine and cosine, and others later. That's still 1, so my terminal point is a point 0, -1. And I remember that the sine of an angle is, for now, defined to be the y value of my terminal point, -1 being the y value of my terminal point. Okay? So there are 4 problems I want you to consider for now. What will the sine of 180 degrees? And while we're there, what's the cosine of 180 degrees? And what would the sine of -270 be? And while we're there, what would the cosine of -270 degrees be? Okay? I want you to think about those problems. We'll talk about them tomorrow, and we'll see you in class. Bye-bye.